Assalamualaikum and good day everyone. Welcome to Dynamics course SEMM 1213. Let's dive in. Dynamics is a subject that deals with motions of particles and rigid bodies. Particle and rigid body are our idealized models to simplify the analysis of actual physical objects and systems. We assume an object to be a particle when its dimension can be neglected, or as a rigid body when its dimension must be taken into consideration during analysis. Mass attributes can be attached to both particles and rigid bodies. Dynamics involves two main areas. First is the study of motions only, which is termed as kinematics study, while the second is the study of relationships between motions and forces that are responsible for these motions, known as kinetics study. Two types of motion are considered, namely straight line motion, termed as rectilinear motion, and motion in a curve, termed as curvilinear motion. Let us start with kinematics of particle, in particular rectilinear motion. In a rectilinear motions, we will be describing the motion of particles or rigid bodies through these scalar or vector physical quantities. These are distance, displacement, velocity, speed, and acceleration. These motion parameters are also used for curvilinear motion analysis, but in a different forms. Distance is used to describe length of path traveled, for example, by a point. It is a scalar quantity with a unit of length. Example of application would be to say, Ali have traveled by car for a distance of 400 kilometers. If we want to know where Ali traveled from and to, distance parameter is not enough. We need to use displacement parameter instead, since displacement contains the point of reference for motion as well as the direction of motion. Displacement is a vector quantity with a unit of length. In a simple word, distance is the magnitude of displacement. Displacement may also be time dependent. Velocity is used to describe the rate of change of displacement. Since displacement is a vector quantity, velocity, which is based on displacement, will also be a vector quantity. As the time taken to change displacement value gets smaller, the value of velocity goes higher. Direction of velocity will always follow the direction of displacement that represent the direction of motion. The magnitude of velocity is called speed. Both velocity and speed have the unit of length per time, or in other words, the unit of displacement per time. Acceleration is used to describe the rate of change of velocity. Since velocity is a vector quantity, acceleration, which is based on velocity, will also be a vector quantity. As the time taken to change velocity value gets smaller, the value of acceleration goes higher. Direction of acceleration will follow the direction of velocity if the magnitude of velocity increases. However, if the magnitude of velocity decreases, acceleration will act in the opposite direction compared to velocity. This condition is called deceleration instead. Acceleration has the unit of length per time, or in other words, the unit of velocity per time. Now let's say displacement is represented by a symbol S. Thus velocity, represented by a symbol V, which is the rate of change of displacement, can be written in the form of differentiation of S with respect to time t. V equals to ds over dt. Following the same concept, acceleration, represented by a symbol A, can be written in the form of differentiation of V with respect to time t. A equals to dv over dt, or in the form of differentiation of S with respect to time t twice. A equals to ds squared over dt squared. Integration is the inverse of differentiation. Thus, displacement is obtained by integrating velocity with respect to time, while velocity is obtained by integrating acceleration with respect to time. The relationships between displacement, velocity, and acceleration, which are given in the form of differentiation and integration equations, can be illustrated in graphical forms as well. Velocity is the slope of displacement versus time curve, while acceleration is the slope of velocity versus time curve. On the other hand, area under the velocity versus time curve will give the value of displacement within certain time period, while area under the acceleration versus time curve will give the value of velocity within certain time period. One needs to be well versed in using both equation and graphical representations of displacement, velocity, and acceleration for solving problems in dynamics. The relationships between displacement, velocity, and acceleration shown in previous slides are general equations that valid for all cases. However, certain problem allows further simplification to be made. For example, in the case where acceleration in the system is known to be constant, either zero or non-zero value, following equations for constant acceleration can be derived from the general equations. Using these equations will definitely ease the solution process. However, bear in mind, these equations are valid only if constant acceleration condition is met. By examining the graphs and figures, certain behaviors can be shown. When accelerations are constant, acceleration versus time curve will always be horizontal. Thus, velocity versus time curve will always be made up of straight lines, while displacement versus time curve will contain curvatures. Furthermore, at the point where velocity becomes zero, the particle or rigid body will change its direction. Therefore, we know that for a particle or rigid body, its velocity will be zero when it starts from rest, stop moving, as well as when changing direction.